space industry is quite active and quite special.
There is no job where you don't have multidisciplinarity. You have to be curious and to not just do what people ask you to do.
Every day I start working on communicating with Russian. It's a completely different work for me.
Every field you can imagine, you can find a way to have an impact in space exploration. The number one difficulty is to find what you really like and what you really enjoy. If you found what you like, then the most difficult step is already done.
So really, go for it. There's something in space that I think unites people. There's lots of countries involved there, and they all work together amazingly well. I think it's way more important than we realize. I'm hoping for a bit more women in the space industry because we are not that many, and sometimes when you see panels, it's all male, and you think, okay, are there any great women? Yes, they are. So I'm looking for a more diverse space community.
And to go further to the moon, to Mars, and so on.
We really produce something which people want. The data our satellites deliver to our end users is something which makes a difference even to everybody's daily life, because every weather prediction you see on your smartphone, on the TV screen, does rely on the data we deliver. And being part of that process, of that organization, is great. My job is to make sure that the original user requirements of the National Weather Services are finally being met by the satellites being flown in space. A user requirement could be, for example, high-resolution wind speed. And requirements engineering makes sure that the final satellite, the instrument, the ground processing all work together such that the wind speeds which are produced meet the requirements of our users. I think Darmstadt, and especially the area, offers a lot for work-life balance. You can go, in 20 minutes you are in the middle of the Odenwald, in the forest, you can go hiking, you don't see anybody. I personally do a lot of mountain biking there, and I can even cycle to work. And on the other hand, if you want to see city lights, you drive 20 minutes and you're in Frankfurt. And if you want to go even further, you're at the airport and you can basically fly everywhere from there.
I work at UMETSAT as a remote sensing scientist, and my focus is on sea surface temperatures and sea ice surface temperatures from satellites. So I've always been interested in science and the environment, but I wanted to do something that meant something and that actually helped people. So working at UMETSAT gave me the opportunity to combine all of these different interests. I think the job I do here makes a difference in the world, as well as affecting weather forecasts. It's also important to understand a changing climate. So we need to know the best possible knowledge of our ocean and the ocean's health, so that we can monitor it and then understand how this may change in the future.
So the most exciting and rewarding part of my job is obviously when we have a launch and we get the first telemetry to the ground segment we just built, and we have the first payload telemetry coming in and the products coming out. This doesn't happen every year, but we are working several years towards such a target. I believe the job I do makes a difference, especially when you watch weather forecast on the TV in the evening, which is made with images or data we provide from UMETSAT. And also, for example, in the recent hurricane events in Florida, we provided support to NOAA to do their own forecast and see where the hurricane would go. So I really think it makes a difference.
Since the 1980s, OIP Sensor Systems has been an electro-optical partner for ESA. OIP developed custom-made high-performing optical payloads to provide images of planets in renowned missions such as Proba 1, Mars, and Venus Express. Our compact visual monitoring cameras are used to monitor the effective performance of space mechanisms and to make scientific images to be studied down on Earth. OIP's spectrometers support ESA and other space partners in planet observation missions, such as Proba 5. Those spectrometers are also used by scientists to analyze the Earth, Mars, and Venus atmosphere on board of Altius, Nomad, and Swarm. If you are looking for high-performance visualization from Earth to space, OIP is your partner by excellence.
Space is part of our lives today, bringing many benefits. In the near future, space will become an even more important part of our lives. There's numerous technologies to work together. Space applications and services, developing and delivering technology and services, bringing the benefits of space to Earth for more than 30 years. Prepare, develop, and operate equipment in space for our customers such as the European Space Agency and NASA. Our strategy is to identify the right question, do the research, and develop the most suitable solution. Today, we already provide anyone regular and frequent access to space. Of novel products that do not exist on Earth.
Oui.
We train the astronauts of tomorrow, and we keep those working in space healthy and safe.
Oui, 10 minutes. 10 minutes. Ouais. Je te dirai, 10 minutes. À 52.
These will be the industrial powerhouses driving tomorrow's emerging markets, providing advanced materials and medicines. In the next decade, not only will we harvest the resources that are plentiful in space and which are depleted or scarce on Earth, but human settlements in space will use these resources in their lives.
L'accueil des entreprises internationales dédiées aux applications spatiales. D'un côté, le centre ESSEC de l'Agence spatiale européenne à Redu. De l'autre, le parc d'activités économiques de Galaxia, développé par Idelux à Transine, qui comporte un centre d'entreprise, un incubateur de start-up, l'ESSEC Galaxia, l'Eurospace Center, le Galileo Integrated Logistics Support Center de la Commission européenne ou encore Vitro G7. Un ingénieurs, équipes pluridisciplinaires, startups et étudiants, des hommes et des femmes venus du monde entier s'y côtoient chaque jour au sein d'infrastructures modernes et innovantes, d'où naissent des projets de grande envergure, comme la gestion de l'opérationnalité des stations du système Galileo. Travailler au pôle spatial Radiofrequencies, c'est faire partie d'un espace de mobilité situé au cœur de l'Europe. Entouré de grands axes routiers et le long de l'autoroute E411, le pôle bénéficie d'accès fluides et rapides depuis Namur, Bruxelles, Luxembourg et tous ses environs, en voiture et via les transports en commun. Travailler au pôle spatial Radiofrequencies, c'est faire partie d'un espace authentique et naturel. Lieu de gastronomie et de patrimoine, la région entourant le pôle offre des occasions de sorties variées, telles que le festival de Chasse-Pierre, la foire agricole de Libramont, Libin et son musée Mudia, ou encore le village du livre de Redu. Ces infrastructures sportives modernes, son cadre naturel propice aux balades et ses nombreux lieux touristiques comme Bouillon, Bastogne, Turbuy ou encore La Roche-en-Ardenne. Travailler au pôle spatial Radiofrequencies, c'est faire partie d'un espace culturel porté par de nombreux centres urbains rapidement accessibles. Namur, Luxembourg, Liège, mais aussi Marche, Rochefort ou Libramont. Situé à seulement 40 minutes du pôle, Namur propose une vie citadine dynamique et de multiples activités culturelles, musées, théâtres, expositions ou encore concerts. Travailler au pôle spatial Radiofrequencies, c'est faire partie d'un espace de vie de qualité pour développer un réseau de connaissances et fonder une famille. Logement à prix accessible, proximité de centres hospitaliers ou encore universités, haute école et écoles internationales sont autant d'atouts essentiels pour le bien-être des habitants de la région. Vous aussi faites partie du pôle spatial Radiofrequencies. Rendez-vous dès maintenant sur investinluxembourg.be.
My name is Nicolas Gérôme. I've been working for 3 months here at Vitrocizet Belgium in Transin as a ground system engineer.
My name is Lise Mouton and I am a recruiter and employer branding at Vitrocizet Belgium.
My background is engineering for 5 years, and the purpose of my job is to be sure that there are not any issues with the infrastructure on the Earth for the signal coming from space.
Well, my background is a bachelor degree in human resources management, and I joined Vitrocizet Belgium 2 years ago, firstly with an internship of 1 year, and now for the undefined contract.
I chose Vitrocizet because I really wanted to work in the field of space, and after my master thesis they asked me if I wanted to join the team, and I said yes directly.
First of all, I was afraid because I didn't know nothing on the space domain, but all the colleagues explained me their job, the duties.
I loved space for a long time now, so I wanted to work in, not only for passion, but to work. Every day is different because you don't know what really you have to do. Sometimes you have to plan to go on travel somewhere. Sometimes you have to work on a project.
I chose to join the company because they were open to have a junior profile.
What I really like here, it's a family-sized company, so it's not too big, so it's really easy to talk with people if you have an issue or something.
Everyone knows everybody. We are around the same age, and there is a good atmosphere, good ambience.
They have strong knowledge in the Galileo program, so for a young engineer as me, it's really interesting.
It's exciting to work for a space company. Everyone can have an access to join the space domain, so why not you?
Space and its exploration has fascinated humans since centuries. We sent a few space probes in the solar system. We have even sent robots and rovers on Mars surface to explore it. And we even had a few city trips on the moon. We also have people living in space in the International Space Agency every day since Definitely we cannot do that because we need for our life oxygen, water and food. And those elements represent massive amount of weight that we cannot just send on Mars. So we need to recycle the true waste to be able to sustain their life during space exploration, long-term space exploration. And this was the idea that was developed in the MEDISA project by the European Space Agency 25 years ago now. In the MEDISA project, the scientists are trying to build an artificial ecosystem will allow recycling all true waste, urine, CO2, but also fecal materials if needed, to produce oxygen, water, and food to sustain life of crew during years of mission. In the University of Moens, we are working on oxygen production based on cyanobacteria using different nitrogen sources. The University of Moens also participate in this space exploration and try to develop new methods to follow and optimize oxygen production by those microorganisms. Those projects also have a lot of application on Earth because treating nitrogen waste, urine for example, using cyanobacteria is also a major challenge for space but also for Earth application. If you want to learn more about this, just follow my talk about the MEDISA project and the human's implication in producing oxygen in space using cyanobacteria.
And also to make some networking with
yes
with professionals.
yes
okay.
of course
okay.
of course yes.
Okay, so thank you very much.
Thank you.
So I go to Julien Béclard. Julien, you are one of the boss of Belspo, but Belspo is a very strong support for Switch to Space. Can you explain why you support so much Switch to Space?
Yes, of course. We have been supporting Switch to Space since the first edition because we really think that we need those kind of events to talk about space and to let the students and the freshly graduated students know that space is not only for engineer. You can have a brilliant and a fascinating career in space even if you're not an engineer. So we are very delighted to be here today and to support this event.
So it's the second edition of Switch to Space. We have made the first one 2 years ago. 2 years ago, we have changed it. It was in live. Today, it's a little bit, it's remote. It's remotely, and now it's partly remote and partly in live. And there is a lot of events like Switch to Space in Belgium, or it's something unique?
To my knowledge, Switch to Space is very unique. That's the reason why we're going to keep on supporting these kind of events, because it's a one life opportunity. It's one kind of event. So we are very happy that you organized, Dominique. And I have to congratulate you because I heard that almost 1,600 people registered to the event. So it's the perfect proof that those kind of events are very relevant for many people. So congratulations.
Thank you very much. Yes, I saw that you have people from Brazil, from Guatemala, from China, from the United States. So I think really Switch to Space is something very important for students and young professionals. So thank you very much. So maybe I can ask you. Well, what is your name and what are you doing?
My name is Sylvie Geremans and I'm a student in the Masters of Space Studies at the KU Leuven along with UGent. I'm actually here because I have a legal background and I'm looking for a subject to write my thesis on, and I think this is a great departure where I can find inspiration.
Okay, thank you very much. So I go to you. A lot of girls, but
yes, so my name is Arthur van den Bossen. I'm a law student. I just finished my aerospace degree in Leiden University, just north of this country. I'm just here to network mostly and to just be updated on the most recent developments in the Belgian and European space industry. And I think that's mostly it. Yeah, just network and see what's going on.
Okay, I will ask you, Maud. Come on, because you are present at the beginning of USpace. Explain.
So USpace was launched a couple of years ago with Dominique at his head, and it was really a great opportunity to get students and industry around the table. And for now, it's really, it's been growing for the past couple of years, and it had created partnerships, internship opportunities, sorry, and also a lot of momentum around the space industry. So congratulations on that, Dominique.
Okay, and what are you doing now?
So currently I'm a business development manager for VOWare Space, which is a Belgian company which develops actuators for small sats. And it's a very interesting place to be in. And if ever you're looking for an internship, we're looking for people, so don't hesitate. Thank you.
Thank you, Maud. And you? May I ask you who you are?
Yes.
Give me your name.
My name is Hélène. I also recently graduated from the Air and Space Law program in Leiden. And I'm here because I was here also 2 years ago in the first event. And I remember it was a great opportunity to get to know people from the industry. So that's also the reason why I came here today.
So you remember the first time of Switch when we are numerous, we are more than 600. Well, COVID obliged us to make it remotely, but anyway. So I can maybe ask one of our speakers. We have 1 more minute. So what do you think about Switch to Space?
Yeah, well, I guess it's a good opportunity for not only students, but also probably from people, professionals from other sectors that want to switch their activity sector because they are bored of being in banking sector, for example, or other, and they want to try a new, passionate, and a very attractive sector, which is space. So I guess it's also an opportunity for them.
Thank you. Thank you. And Michael?
Yeah, so I only discovered Switch to Space a few weeks ago, so
it's new.
Yes, my core business is not the satellite, so I work for the National Regulatory Authority. So my main business is the mobile networks. So satellites is only a minor part of my business, but
okay, fine, thank you. I think it's time, or maybe we have 1 minute more. Sarah.
Yes, I actually wish that Switch to Space already existed when I was entering the job market. Then it would have been a lot easier to connect to people, to find a job in space, to know what is out there. So I think it's a great initiative anyway.
Okay, thank you, Sarah,
thank
for
you.
coming to be here with us. Thank you. I will present. So maybe we can start. What time is it? Oh, not. It's time. Okay, so I will take the floor. So good evening wherever you are, be it in Belgium or somewhere else in the world. We have more than 30 nationalities, and this is really great. So students and young professionals, this event is made for you. And do you know why? Because we realized from our visit to numerous universities that most of you love to watch launches of new spacecraft, love movies and pictures from space, love to see astronauts working on a rocket. But many don't think to embark on a career in the space sector. Isn't it strange? This is really unfortunate because the sector is in good shape and continues actively to recruit. So where is the problem? You are attracted by space, but you don't think to work in the space sector. Personally, I see 2 reasons. The first one, the sector is too discreet and stays too much into its inner cycle. The second reason, the career perspective in space greatly expand today in many fields: medicine, agronomy, biology, economy, defense, security, law. The diversity of this scope is not yet well known, and it's still difficult for students and young professionals to find an overview of the numerous possibilities of jobs in space. So, decision and action. The super Belgium Switch team decided to launch the 2nd edition of Switch to Space. More than 40 experts, space experts, during 8 days will share with you their expertise, explain various opportunities of career prospects in space. They will share insights into the individual path, their job, their vision of the future of space in an accessible way. So, just to help you to find the best way for your future career. Keep this in mind. Don't forget it. In the next future, most of the jobs will be linked to space. Yes, definitely. Switch to Space is the key to open the path of the possible. Make your professional life exciting and enjoy Switch to Space. Thank you. I have to present now yes, please, Amélie. So I would like to present you our 2 switch leaders for the topic 1. It's Amélie Revers, Amélie, and Alexis Pharmakidis. Both, they are good examples that shows that that's not only scientists who are working in the space sector. Let's see. Amélie. Amélie, she has a law degree. She is responsible for the Department of Human Resources for the whole group of Vitrocizet Belgium. The company is established in the province of Luxembourg, this is in Belgium, and present as well in many countries in Europe. And she joined the Switch team because she would like to extend her knowledge in space, about space. So Alexis holds a master's degree in political science, international relations, technology, space-related science, and politics are his passion. Today, he's working as a project officer in space research for the European Commission Research Executive Agency. Now I give the floor to them and they will present Sarah.
All right. Whoops, 1 minute. One minute.
Thank you, Dominique, for the presentation.
Yeah.
So I would like to present Dominique as well. I think there is a problem with the microphone. So after a career of 27 years in politics market by an active involvement in the space sector through chairing the Space Group Senate and leading the European Interparliamentary Space Conference, Dominique launched USpace in 2014 in order to link students to Belgian space experts. She is currently the chair of EURISI, member of Researches at Belgium, member of the advisory board of SP, and VP of the International Aeronautical Federation.
And just one moment, so I can introduce Sarah Moens, who is the chair for our first topic. So, Sarah is a lead lawyer at DLA Piper in Brussels and has expertise in public and administrative law, with a particular interest in litigation matters and public procurement. Furthermore, she is experienced in space law and drones law. She is a board member of the European Center for Space Law and an elected member of the International Institute of Space Law. Sarah also guest lectures on drones law and space law at various universities, such as Université Paris Sud Leuven, Université Leiden, Université Ghent, and during specialized summer courses. Furthermore, she is a speaker at national and international conferences. She is author of legal articles on drones law and space law. Sarah, the floor is yours.
Thank you, Alexis, for this nice introduction. I will first share my screen. Voilà. And so I would like to talk to you a bit about space law, our topic of today. First of all, we're gonna check how can I become a space lawyer. I will give a short introduction to space law, to what lawyers do in outer space, and I will present the speakers of today. I will also make sure that the speakers take their time, but stick to the 15 minutes that we have reserved for them. You have heard my biography. Thanks to Alexis, we already have gone through this. So this means that I can start with my favorite quote, per aspera ad astra. For those who do not know any Latin, you might have heard it because it is the quote of NASA, the NASA from the USA, and it actually means to the stars through difficulties. And through the stars to difficulties is not only representative for the space sector, because they're literally, you go to the stars, but also I found it personally a quote that is really capturing how looking for a job in space law is. For me, I experienced it as a difficult way, but a way to the stars where you finally can find the job that you are looking for. So this presentation is also a bit to encourage you. We were asked to give a bit more insights about our own career that might maybe inspire you to go a bit the same way. So this you will find also in my presentation of today. I would like to give you some tips and tricks while you're still a student. A very important one is go looking for internships in the space sector. And why is this important? Because I was talking already today with some of the participants, and the most difficult thing is having the first experience. When you are looking for a job, people always ask for what kind of experience you have. And this is not so easy when you're still a student, of course. So go for these internships, although maybe they're not paid or they're not in an ideal situation or a location. It is an interesting way to start. You can also study space law. Later today we will hear Bart Munters, who is teaching at KU Leuven Master of Space Studies. It's also organized by Ghent University. I give their guest lecture. You have also Université Paris-Sud 11, which is in Paris, has a master in space studies and telecommunications. And then we have 2 LLM programs at Leiden University and McGill University. But you can also do a summer course. For example, at the European Center for Space Law, we are organizing a summer course every year. Due to Corona, it was a bit more limited this year, but we hope to organize the 2-week course again next year. So go look for these studies. Do not hesitate to do them. Some universities also have a master's degree or a master's study, a subject you can take, for example, at Ghent University. So it's good to have that first experience in one way or another. And then after your studies, even you're not working in the space sector, you can still stay involved in space, because to stay connected, it's very important. Use space with Switch to Space is one great opportunity, but there are many others. And you can become a member of Use Space, ECSL. If you don't know ECSL, Google it, because it's very interesting to see what the program is there. You also have the Space Lab project group from the SGAC. And in Belgium, you have B-Space. I founded it a couple of years ago together with other people, and it's still working very well. Go check the website out, and these are opportunities to get connected to the space sector during your studies or after your studies. This brings me to an introduction to space law. I would like to talk a bit to you what is space law. Star laws, yes, it's the laws of the stars of the universe, but of course it's a bit different than only that. It's actually the body of law that is governing space-related activities. So you have international treaties, you have EU legislation, there is even national legislation. In Belgium, we have national space legislation. And this is on a variety of matters. You have liability for damage. What if a satellite falls down on Earth and is still intact and causes some damages? What if a satellite has a problem when it is still in outer space? What is international cooperation looking like? Speaking of international cooperation, we do have the United Nations Office for Outer Space Affairs, which is a UN organ based in Vienna. So on an international level, a lot is going on space law. We even have some United Nations treaties on outer space. You see some examples there. The most important one is the Outer Space Treaty, because this covers all the principles governing the activities of states in outer space. We have the rescue agreement. What happens when an astronaut, let's say an astronaut of the US, falls down from its spaceship and ends in the desert in Kazakhstan, and what is going to happen? The rescue agreement tells us that we have to safely bring back the astronauts to its country of residence. Liability convention, and what happens when there is damage caused by space objects. The registration convention, you need to register every object that is launched into outer space. We have the Moon Agreement, which is not signed by many countries, but still it is there, and it deals with what happens on the moon, what can you do on the moon, which is also very hot topic nowadays, because we have countries that would start to do commercial mining of celestial bodies. So this is actually our basic principles we're working with in space law. The background is the 60s. At the time there was a Cold War between the Soviet Union and USA, and actually the countries were a bit afraid that if one of the other country would be the first on the moon, that it would actually claim the moon. So they want to prevent that there could be a war in outer space, and therefore they created the Outer Space Treaty with fundamental principles as space as the province of all humankind. And it is for everyone. Everyone can go to outer space freely. It is for everyone, for all humankind. And there is a freedom of exploration and a use of outer space by all states. So although US or UK, we know now who would be the first on the moon, but at that time it was not sure yet. No matter what country was the first, there would be a freedom of exploration and a principle of non-appropriation. And this means that one country could not claim the moon, although they were first on the moon. So the flag on the moon of the United States, it was a political act, but not a legal act, because already in the Outer Space Treaty, they agreed that there cannot be any appropriation. You cannot own outer space. Now, why is outer space still important for lawyers today, for example? You might be surprised of the number of applications there are for Earth observation data by lawyers. For example, there are criminal investigations, environmental investigations, border disputes, human rights investigations. So there are many applications of one aspect I've taken out now, Earth observation data. Why? Because there's many possibilities, because you can be at any place you want to be. Even in Greece, there were illegal swimming pools detected by using satellite images, and the people who did not have the right permit for it, they received a fine based on the satellite images. Also, to detect illegal oil spill at sea. Here you see an MVSat image in Spain, and there it was, they could see where the oil was coming from, and they could even detect eventually the ship that had released the oil. The International Criminal Court, which is an international court that deals with several crimes, for example, crimes against human rights, they use satellite images in the case against Al-Mahdi. Al-Mahdi was an extremist with connections to Al-Qaeda, and they created a digital interactive platform to actually demonstrate that several mausoleums and a mosque were destructed in Timbuktu. Oh, this was too fast. Also, the International Court of Justice, you might know the International Court of Justice as the organ from the United Nations. There was a case, Qatar versus Bahrain, and they were disputing about the Hawar Islands. The Hawar Islands were islands somewhere in the middle between the two. It was discussed whose territory it was, and then the decision was taken in favor of Bahrain based on satellite images. Also, Hurricane Katrina passed by in New Orleans, and there they could actually see on a picture that the destruction of a house happened after the hurricane passed by. So on the picture, the house was still intact and all the others were destroyed by Katrina. So the owners had caused the destruction themselves. So you see, space law is very broad. I've just taken out some some topics to explain to you why it is important and what can be done with it. Something very hot topics, Earth observation data today. You see it in the news, but you're not always aware that lawyers can use it as well. So I hope by this introduction, you know now a very bit more about space law. And our speakers of today will dig into topics specifically dedicated to space law or space policy. And therefore, I'm very happy to introduce to you our speakers of today. Our first speaker is Mr. Wart Munters. Wart Munters is a doctoral researcher and a teaching assistant in public international law at the Institute for International Law and Leuven Center for Global Governance Studies at the KU Leuven in Belgium. He's an assistant coordinator for space law, policy, business and management in the Master of Space Studies, the one I was telling you about. And he's also focusing on space debris, space object collisions, and space traffic management. His research aims to uncover fruitful theoretical perspectives on orbital space law at the nexus between age-old terrestrial legal logic and astronautical reality of orbital space. The title of his presentation is Space Traffic Management, Paving the Way or Establishing Dominance. Wart, the floor is yours.
Hello, everybody. Thank you, Sarah, for this very kind introduction. Let me just begin by saying it's an honor to be here once more. I was already part of the first edition, so it's good to be back. Unfortunately, remotely instead of in person, but we'll make do. I've also heard and seen a couple of familiar faces, both from previous years and of the current year in the Master of Space Studies. So hello to former and current students. Let's get started. Let's see if I can share my screen here. Huh? So I hope my screen is being shared correctly. Let's get on with it. So just first a quick note on space careers. Or let me just start with a different little topic, something I've taken to use to really sketch the difference or what makes space law different from other areas of law, in my opinion. Well, the present world record for a ship, a sea ship, a nautical ship, a manned ship, circumnavigating the globe across the oceans is 40 days, about 41 days actually. The world record for manned air travel by an airplane is 46 hours. Now, it takes a satellite in low Earth orbit up to an altitude of about 2,000 kilometers, approximately 128 minutes or less to circle the entire planet. This tells you that we're dealing with a completely different environment and a completely different mode of interacting between actors, between legal subjects, and between nation states as we try to study in international law. So what makes this environment such a good place to start a new career or to maybe pivot your career into? Well, first of all, there's a number of unprecedented developments happening right now, namely militarization. Look at Space Force, look at Chinese military maneuvers, look at France, look at the new Director General for Defense, for the defense industry and space at the European Commission. There's ongoing commercialization. I mean, Elon Musk's Starlink has grown to be the biggest commercial constellation in orbit in less than a year. So there's increased traffic, but increased traffic also brings along increased non-functional objects, namely when satellites stop functioning, namely space debris. And because space is growing ever more important, we're seeing a wave of national space legislations. Every country needs space for its economy, for its industry, for its national security interests. So every country is now also adopting national space legislations. And that brings with it a need for more space experts, young people that know what they're talking about. Indeed, space is transversal, so the profile that these people need to have is very interdisciplinary. Space is transversal as well. It has links to myriad activities and fields. So, for example, maritime transport has a very important space component, environmental management, agriculture, you name it, military. Everything you can think of probably has a node and a network up in orbital space. So it's very important to approach the problem both from a STEM perspective as it is to approach it from a humanities perspective. So for example, you need people that can contribute to high-tech R&D, but you also need people that know how to navigate and analyze space markets from an economic perspective, or you need people that know how to create and apply or criticize space law and space policy for all of these new entities becoming active or furthering their interest in space. So at the KU Leuven, together with the UGent, we co-jointly organize a Master of Space Studies program, and a couple of our students are in the audience today. Hello again. It's an interdisciplinary advanced master's program, and we offer a number of introductory courses and a Truncus Communis, a common program that all students joining the program must take. So some of the classes in this common program are space law, policy, business, and management. So also space engineers or people with a scientific background need to have space law. People coming from a law or humanities background get engineering design of space missions and spacecraft components, including orbital mechanics. Why is that? Well, because I personally believe, and I think my although short-lived experience up until now has confirmed it, if you want to have something meaningful to say as a space lawyer nowadays, at least in my particular little niche of the field, you need to have at least a basic grasp of orbital mechanics. Otherwise, you're just talking about things you don't really understand. Likewise, engineers need to have at least a basic grasp of what ITU, International Telecommunication Union regulations say about electromagnetic spectrum apportionment. Astrophysicists, and I believe we have an esteemed speaker later in the panel that will talk about this particular program, astrophysicists are probably interested in space law as well, because there is such a thing, or a new concept called right to starlight. Namely, if I launch a lot of satellites and they start interfering with terrestrial astronomy, what does the law say about this? Then after the common program, where everybody gets a good knowledge bath, also in programs that they might be less familiar with, they get the opportunity to specialize in 3 profiles according to your background. So space law, space sciences, or space technology, and everybody writes a master's thesis program, which as much as possible is embedded within existing industry, partners, academic institutions, etc. So if you're looking to launch your career into space, the Master of Space Studies might be a good place to start. Alumni include myself, yours truly, and people now working at high-level positions at the European Space Agency, at BELSPO, at the European Defense Agency, at the EU, various universities, private industry, etc., etc. Now, space is here to stay. Global society depends on space. The recent report by the National Academy of Sciences in the US underscores this fact rather neatly. And management of orbital use is therefore imperative. More actors, more objects are crowding space ever more, and there is little to no specific public international space law as between international nations or international organizations that actually regulates this shared use of orbital space. In my opinion, actually none at the moment. So indeed, my research and my teaching in the Master of Space Studies focuses on space traffic management. Everything basically still needs to be defined and created. We're in a unique and unprecedented situation at the moment. Basically, space law and development of the space environment was put in the fridge in the 60s with the adoption of the Outer Space Treaty, as between the 2 Cold Cold War superpowers. But anno 2020, namely now, we're in a completely different situation where open access and freedom of use of outer space basically means that we have thousands of actors coming from hundreds of different countries using space, and there is no real effective international legal framework to apportion use of orbital space or to even coordinate between these actors at a high level. None whatsoever. So what we're looking at is basically the construction of a droit astronautique, astronautical law. Compare it with the creation of the law of the sea. Think of Hugo Grotius, who wrote about the free seas, Mare Liberum. But not only do we need development, and I think this is very important, I attach a lot of value to this. We don't only need development, we don't only need new space lawyers who apply positive international law, because space law is a very positive field, positivistic field at the moment. We also need people who are able to critically reflect, analyze, and participate in creating these new modes of governance. Because a lot of things that are being sold right now to the public in various forums might not actually be all that truthful. So we need people that are actually able to differentiate between what is propaganda and between what is actual truth. So why my focus on space traffic management? Well, to put it simply, space is extremely large, but orbital space is not unlimited. Orbital space is just a shell, a sphere of space surrounding planet Earth. It's thus a limited four-dimensional resource. A limited four-dimensional resource. The question now is, how do we manage mutual relations between essentially unlimited number of space objects, among them satellites, that all come from different origins that serve different functions, be it military, be it commercial, be it scientific, be it public, be it private, etc. There is very little existing international law on these issues right now, so it basically all needs to be created. Even the conceptual framework lags behind. I posit we don't even know what we're actually talking about at the moment, and anybody that tells you that we do, I say approach their perspective with a bit of caution. Indeed, low Earth orbit is becoming highly congested, contested, and competitive, and that makes for a very dynamic environment. There's open access, freedom of use, and the question then becomes, for who or for whom are we going to develop a space traffic management regime? Only for those existing powers that already use space and have historically used and polluted space? Or are we going to create a space traffic management regime that benefits all countries, even those that might not have a particularly strong space presence at the moment? Orbital use. Currently, these are approximate numbers. There's about 30,000 objects that we can confidently track and catalog larger than 10 centimeters, about 750 larger than 1, and millions below that. Now, when a collision between any two objects of sufficient mass happens, the fragments will start dispersing after a couple of orbits until they envelop the entire planet through a process called chaotic motion. And this, to me, is the central element to legal analysis, also as concerns space traffic management, namely what happens when two objects actually collide. Now, the most startling statistic that I've ever read concerning my field comes from the report by the NASA Orbital Debris Office in 2018, namely that 30% of all resonant space objects currently cataloged in orbit and 13% of all space objects ever cataloged since Sputnik 1 come from just 3 original space objects, namely Fengyun 1C, Iridium 33, and Cosmos 2251. I think that paints a picture of how fragile and how interconnected the space environment actually is. Namely, a collision between any two objects, so a conflict between any two actors in space, or an accidental collision between any two objects in space, will radically change the entire operational environment for every other actor in low Earth orbit. So we're facing a collective action problem of vicious proportions. Unsurprisingly, perhaps, 2018, we get the US Space Policy Directive 3, which did take the world a bit by surprise. Namely, it calls for space traffic management and defines it perhaps preliminarily as the planning, coordination, and on-orbit synchronization of activities to enhance safety, stability, and sustainability. in the space environment. Okay, that's all good and well, but what does synchronizing on-orbit activities actually entail in reality? Well, when you look at orbital space around Earth as a limited resource, and all of the objects inhabiting that limited resource is actually using a limited resource, space traffic management basically becomes a system to apportion the use of a limited resource among different actors. So space traffic management, at least how I see it in its most abstract form, basically means deciding the system of control and the system of management of orbital space. Now that's very difficult because traditionally national militaries have wanted to preserve complete freedom of action. Eisenhower famously, in his ploy to let the Russians launch first, was very adamant to secure complete freedom of action for the US and for US freedom of overflight in orbital space to prevent the new nuclear Pearl Harbor, in his own words. At the same time, we have deadlocks in international forums. But to manage orbital space, you need to know what's actually happening in orbital space. So you need space security data, space available tracking data, and you need space situational awareness data. The US has very powerful systems. They have arguably the best systems on the planet. Space Fence at Wyoming Atoll in the Marshall Islands is the best example. Comparative EU capabilities do not yet exist. And if the EU wants anything to say in the space traffic management debate whatsoever, if it does not want to be reliant on outside sources of data, it will have to start organizing an SST or SSA system of its own. At least that's my opinion. So long as Europe does not do this, it will sit idly by the sidelines and will not be able to actually weigh on any of these developments in a meaningful sense. Of course, people say, oh, can't we use things, international law, the law of the sea? We have the UN Convention on the Law of the Sea. Okay, I agree with that analogy up to a point. What often people forget is that there were centuries of development preceding. Much of it characterized by conflict, brutal wars, and colonial strife and appropriation. Grotius himself wrote the concept of the freedom of the high seas as a means to allow the Dutch East India Trading Company to break existing monopolies and establish its own colonial monopoly. These imperial colonialist tendencies of the regime, I think, still might underlie current STM tendencies and the international debates, and I think this is a very good area for critical reflection and for extra analysis, also for all the students looking for a thesis subject in the crowd.
Bart, if I may interrupt you here, we have reached the 15 minutes, so
okay.
If you can round up your presentation, thank you.
So there's a lot of unknowns, a lot of uncertainties. There's some bad stuff happening. There's a lot of good stuff happening, as we'll hear, but there's a lot of questions that still need to be answered. So if you choose space as a career, you'll definitely find work and you'll definitely find a topic that interests you to work on. So thank you for your time, and I look forward to your questions if there are. I yield the floor.
Thank you so much, Bart, for this very interesting presentation. I have a first question to start with. Are there any international limits to using orbital space? So can they actually be used to support space traffic management?
Oh, that's an interesting question. Sounds familiar. No, there's not. There's Article 4 in the Outer Space Treaty is the most directly applicable one. It basically bans stationing weapons of mass destruction on orbital space, including nuclear weapons. That's basically it. But if you want to look for, if you're asking me to identify a specific quantitative limit, no, there's not. Anybody with sufficient money and sufficient capabilities can start launching thousands, unlimited numbers of objects into orbital space at this moment in time. So my research is basically looking at, okay, if there are no legal limits or no clear legal limits and everything is a case of interpretation, the only thing we can say with certainty, or might say with certainty, is that the limit to the use of space starts exactly where an other's use begins. And that's why space object collisions are so interesting, because this is exactly a conflict of two uses of space colliding with each other, quite literally. So that's the atomization of sovereignty, basically. Yeah.
Thank you for your answer. It's a very, very interesting subject. I'm wondering if there are some questions from the public. If you have a question, you can type it in our chat box. And also the people who are attending here live, please raise your hand and then we will, I see Arthur has a question. Please go. Can you hear it clearly, Mart, or should he maybe come a bit closer to microphone? You can try, yeah.
I know.
We have a microphone there. Please. Thank you.
Okay, so thank you very much for the interesting presentation. I myself wrote actually a thesis on STM, and I see a lot of these things which you're now identifying are also things which I discussed myself. One of the things I was struggling though is if we eventually come up with a system which is workable and which covers the majority of the space actors nowadays, what can we do with events of space weather which are beyond the control of people usually? So even if you have a perfect system which works and which is regulated and which is efficient, if there is a massive disruption by a space weather event which is not unthinkable, would this not be a disaster for STM, and don't need a very flexible system which can envision a large-scale disaster?
Very interesting question. And this is exactly a problem that I approach in my research and in my PhD as well. But let's put it simply, or let me just be quick about it. I don't think we need to hypothesize some catastrophic SSA or solar weather event happening. No. Okay, if that happens, it happens, and we have no agency over those problems. So whatever happens will happen, and we'll deal with it. It's almost useless to speculate about this. What interests me is what happens when a conflict between two actors in space happens, and these two actors both have kinetic direct kill technology that can target satellites in space and start using ASAT. Now, as we've seen, a couple of objects, even if one object disintegrates, look at Space Track, an SL-8 rocket body had 3% probability collision probability just a couple of weeks ago. If one of those rocket bodies explodes or an ASAT event happens, the collision probabilities will change massively over literally in an instant. What we need is exactly a system, like you said, that is extremely flexible. So we're dealing with an environment that has a lot of massive networked effects, a lot of information asymmetries. Only some are in possession of actual data, and they're probably going to use this to leverage their power positions on an international level. So there's people arguing, Cargill Hall was probably the first one, for centralized or decentralized modes of space traffic management. And of course, there's a lot of optimism in industry, et cetera, but when you approach it perhaps a bit too negatively from my perspective, based on the history of the law of the sea and of conflict, where you see that mankind has basically never learned until we've had centuries of strife and conflict, then I hesitate to say that we will be able to actually create such an ideal, platonic ideal of a perfect system. What I think is more likely is that we'll see regional groupings of actors creating their own little collective space traffic management systems. And then the question will probably become how to link up these various more decentralized systems to some kind of shared principled approach at the top. Hopefully with a role for the UN Committee on the Peaceful Uses of Outer Space, but since that forum has basically been deadlocked for the last couple of months, I don't think we should see, we should expect a solution emanating from the UN anytime soon. Yeah.
Thank you.
Thank you for this interesting question. We also received one in our chat box. And the question is there a law to share the orbital position of different space objects which might help new launches of different countries?
This is a very nice question, because actually in my PhD, I love to use some analogies, although these are more poetic analogies than anything else. But it's a little bit like, because I use the term atomization of sovereignty, it's a little bit the shift between the view of the atom and the view of the Pauli principle, the view of within the atom. Namely, electrons will never tend to occupy the same position around an atom, but within the quantum world, quarks, for example, will tend to. So yes, the question becomes, should we not look at orbits more as a public utility, and an orbital position, should it not be open to a satellite that serves multiple functions for multiple actors? Now, the commercial system that we're seeing coming into existence might be a step there. As to legal provisions, yeah, perhaps Article 44, paragraph 2 of the ITU, which says that the spectrum, the electromagnetic spectrum and any associated orbits are limited natural resources that should be used efficiently, rationally, and economically. That is probably the most performative or the most effective or direct provision that we have at this moment in time, apart from more general principles, and for example, the Outer Space Treaty that say that outer space should be free for all, but has since been qualified, for example, by the Space Benefits Declaration of '96 as basically being completely voluntary cooperation. So I don't think we should put too much faith in those provisions having any effect anytime soon.
Thank you, Bart. Maybe time for one other question. I see there are some questions in the Q&A. Let's pick one. How many years do you think will pass before we fill Earth's orbital space and we have to begin large programs to remove space debris or make a priority system for launching things?
Well, according to Liu and Johnson, two of the eminent space debris scientists at NASA, we've long since passed the time. We should have started clearing at least 5 large risky objects from orbit a while ago to start stabilizing the space object population. These populations, although collisions are still far and few between, although they're becoming more probable by the minute, basically, what we need to do is remove a lot of reservoirs of mass, basically, namely in the form of large, still intact objects before they fragment and create shrapnel. We need to remove the kinetic energy that's present as quickly as possible. Now, at the same time, you have people like Elon Musk and a host of other companies from different countries, different systems, different economic and ideological backgrounds, with either plans or already an identifiable presence in space. So we're seeing what the IADC, the Interagency Debris Coordination Committee, calls a step change in the number of objects. Now, basically what's happening here is, well, they're just filling it up factually, and whatever happens legally will happen legally. Now, I think there might be a philosophy, especially among the more powerful actors, the US certainly among them, to basically conduct whatever they want to do in space and to make sure that their state practice, which is a very specific category in international law, contributes to creating new customary international law. So basically, as long as the US does what it does, even if it's unilaterally, it will have an effect on what the complete collection of state practice represents in orbital space, and it will have a certain effect on what might be customary international law coming into effect. So how long will it take to fill up space? Well, I think in LEO, a lot of space debris scientists will say it's already filled up. This long-term perspective that's always used at the UN and all of these discussion forums and at conferences like these, there's people like Dr. Darren McKnight, there's people like the institutions like the IAA saying, no, there's near collisions happening right now. Like the SL rocket body, it had a 3% chance of colliding already just a few weeks ago. If that explodes into fragments, you'll have a complete step change in the number of objects in orbit overnight. And some of these are on geotransfer orbits. So if a rocket body on a GTO orbit fragments, it actually has the potential to start spewing or seeding space debris into geostationary orbit, an orbit that has up until now been spared from space debris because there's a lot more space available. All of these effects are interrelated and indivisible. So it's an extremely complex problem, and the real question at the bottom is, yes, we need to start removing debris. It's going to cost a lot of money. Are we going to start keeping or holding companies and countries that have polluted space historically? Are we going to start holding them accountable or not? That's the question. Thank you.
Thank you so much, Bart. With this last question, I would like to present our next speaker, Mr. Nicolas Gérôme. He is the head of space-based capabilities at Belgian Defense since 2018. He also worked as a network architect for territorial and deployed networks, and he was a business development, defense, and intelligence sector at Luciat. He also holds an advanced staff course and postgraduates in applied geomatics, big data analytics, and space mission design. The title of his presentation is "The Next War Will Reach Space: Why Defending the Peaceful Use of Outer Space Has Never Been So Relevant for NATO, for Europe, and for Belgium." And Mr. Gérôme, the floor is yours.
Thank you very much, Sarah. So you all know that space is a dangerous environment because of vacuum, because of temperature, because of radiation. But nowadays the problem is that it's becoming more and more dangerous because of human activities, and that's what I'm going to talk about. So let's imagine one day that this goes very wrong in space and that the event that we were talking about before are happening and we are losing space services. What would happen? I have here a small video that should start. Start. It's loading. Very sorry for this.
Imagine a day when every satellite suddenly stops working. How would this scenario play out? The day begins with the internet slowing down dramatically. Phone calls to other countries are virtually impossible. TV stations lose contact with all foreign correspondents. And with no GPS signals, the chaos begins. With no data, weather forecasting is unable to warn of imminent bad weather. Fishing vessels lose access to navigation systems. Everyone dependent on satellite telephone is completely isolated. With the speed and accessibility of electronic communication drastically reduced, business and financial transactions slow down, and the global economy follows suit. Meanwhile, traffic lights, railway signals, and air traffic systems start to malfunction, and anxious people are trapped in long queues on roads, in underground stations, and at airports. Drivers are desperate for old-fashioned road maps, but these are sold out. Mobile phones have lost the internet access, which everyone has taken for granted, and people cannot phone home. Next, electrical power grids and water supply systems become unstable. Those responsible for the defense of their country lose contact with deployed units, and soon afterwards also with ships and military bases. Advanced equipment is soon rendered useless. Aircraft cannot operate effectively. Communication with personnel and with allies is virtually impossible. For ordinary people, it's as if time has been turned back several decades. For national security, we are rendered practically defenseless. For an aggressor, the door is suddenly open. So what does it take to safeguard these services today and in the future?
And I thank my colleagues from the Norwegian Ministry of Defense for this very nice video. What threats are we talking about when we're talking about human activities in space? I'm talking about threats, so from human nature and not hazards, from natural nature. You see here a spectrum of those kind of threats, from the very left reversible threats to the right non-reversible, very permanent threats. And the very bad news is that all of these, let's say, weapons of way of attacks or hostile intentions have at least been tested once. And even the nuclear detonation in space, it occurred several times in the 60s and 70s. ASAT missiles have also been tested, and co-orbital threats have also already been tested. So this is not fiction. And it's not only the variety of those threats that is worrying, but also the intensity in occurrence and the frequency now in the last years. So for example, 2 years ago, there was the first publicly accusation from the French Minister of Defense towards the Russian for spying of their military SATCOM satellite. It was the first time that it was publicly blamed in the media. Last year also, the mission Shakti, which was the testing of an anti-satellite weapon from India. They did it a bit more properly than the Chinese 13 years ago, but still there was a lot of debris generated, also at the altitude of the ISS, which is obviously worrying. The ILU Starlink near miss of last year as well, where a big ESA satellite was very close to a collision with one of the first Starlink satellites. And the awkward silence from SpaceX at that time was kind of worrying for a company that intends to send 42,000 satellites in orbit in the next years. The same this year in April, the Russians did a test of their anti-satellite weapon that can reach LEO and probably also MEO, and they also have a version that might reach geostationary orbit even. And a few months ago only, the Russian did some kind of kinetic test from their Cosmos 2543 satellite with a relative velocity of 7 miles per hour from the original object, which is clearly a test of a kinetic orbital threat. And the allies are also doing some stuff that we do not exactly know what they're doing. So, for example, the X-37B from the US is also a spaceplane, reusable spaceplane that might be used for satellite servicings. But when you develop techniques for satellite servicings, you also develop technique for satellite sabotaging that you can do with the same kind of technologies. And the more worrying, the cheapest and the most, let's say, occurred threats that we encounter is this one. It means GNSS jamming technology. From very cheap device that you can buy for 25 euros on Alibaba to very specific dedicated jammers that are airborne or shipborne. This is now becoming systematic on all of our operational theater, especially on Ukraine, Baltics, Syria, and also even in Libya now. So the situation is a bit comparable. My colleague Ward compared it to the naval law. I compare it to the air domain, where in 1914, when the airplane were very scarce, the technology was new, it gives a strategic advantage. And above the trenches, the French and the German pilots were in a very small community and they were waving to each other. Till one day, one of them took a gun, and it was the beginning of the Air Force. And the bad news is that we are now at this stage, roughly in space, where the weapons exist. They have been tested. They have not been used yet, but you see an increasing number of, let's say, hostile incident or strange behaviors that are worrying and indicating for a not good future. So space is a strategic enabler for the economy, for the defense, and for many services. And for Western defenses, it's a fragile component of our technology-dependent forces, because doing a war with zero policy and smart bombing requires a lot of space services. It's becoming a complex, congested, and contested environment. It remains an essential domain to express warfare supremacy. And there is, with now the new space, there is a difficult reading of a lot of new actors that are entering space, private actors, smaller countries, non-state actors, where you don't always know what they exactly want to do. You have seen that space is occurring in an environment which is, let's say, a legal vacuum, or even sometimes some people are referring to the Far West. At least there is lacunary of international law regulating space, or obsolete. So these all combined show that the next war, the next conflict of a certain size, medium or global size conflict, will certainly have impacts or components in space. Why do military use space today? We use obviously space for intelligence, for imagery intelligence mostly, but also signal intelligence, for Earth and space weather, for satellite communication. Obviously, when you are deploying units everywhere in the world for expeditionary operations, you need a lot of satellite communication. Positioning, navigation, and timing. Military are addicted to GPS, and they are not always trained to work without. And ballistic missile defense is also an increasing threat when you are developing a new launcher. It's the same technology that is used for missiles. And today there are a lot of new launchers that are being studied. So it means that for the future, we can expect a lot of new countries to have ballistic missile technology. To operate in space, you need space domain awareness. I guess this is already understood now from all of you. You need to defend your space assets with defensive space control, with passive and active measure to defend your space, your own space assets. You can also attack the one of the others. This is forbidden in a NATO context, but this doesn't prevent some NATO countries to have this kind of doctrine. And that's explaining why a lot of countries are now restructuring or rethinking how they are structured with their military component of space. The Russian have Space Force since 2001, the Chinese for 5 years already. So the Space Force in the US is not really new, it's more, let's say, a synergy of all components of the US DoD dealing with space, and it creates actually the biggest organization in terms of number of launch or budget dealing with space with a bigger budget than NASA. So the French have also restructured their Commandement Interarmées de l'Espace, which is now Commandement de l'Espace, and also at the smaller scale, many countries are developing the kind of similar concept. When you see among the military satellite landscape that NATO owns a big part of those, and you see that the two other big players are Russia and China, you see that it's a reason why NATO declared last year in the summit of London in December, space as an operational domain on the alongside land, air, sea, and cyber domain. The same criteria were used for declaring cyber as an operational domain 4 years ago, because there are many similarities between those two domains. It is an inherently global environment requiring unique capabilities to operate. And the biggest importance in this declaration is that any conflict that extends to space has the potential to affect all users of space. So even a small conflict between two countries will become global because of the debris generation of some possible debris generation or consequences in space. So the free access, exploration, and use of outer space for peaceful purpose should be the common interest for all nations, and that's all what the NATO nation agreed about. Space is also essential to the alliance for deterrence and defense. So that's why NATO is implementing now their overarching space policy alongside this declaration of a domain to provide more space support to NATO operation in the preparation and execution of military operation, and space as an operational domain is just one facet of it. So space is used for deterrence and resilience of different type of services. Within NATO, nation will agree on capability development and interoperability standards for space services. They will do training and exercise together. There will be strategic communication about this, of course, science and technology panels and research activities with NATO budgets, and industrial partnerships will be created. But NATO is not alone with a new focus on security for space. The EU as well. There are new components in the space program dealing with security like GovSatcom or EU SSA. There is the creation of the DEFIS in the new commission, so the DG for defense industry and space. In the European Defense Funds for the framework 21-27 in the EU, there are several space-related programs. Space has been declared as a capability development priority for the European Defense Agency, and I can still mention also the 3 SOS initiatives from the External Action Service, so security, sustainability, and safety of the outer space. What in Belgium? In Belgium, we would like to have a safe, secure, sustainable, and resilient space environment that allows Belgian economic, industrial, academic, public, and defense stakeholders and citizens to fully exploit the benefit of space. So it's a very nice utopic vision, but we want to strive with that. We cannot achieve that as small Belgium, of course. So we need to include this strategy in a multinational environment, in an EU context and in a NATO context. So how can we conclude? This is the Minister of Defense, since 2 days, not anymore, dealing in this very same building in January, explaining why security and defense dimension of space is becoming increasingly important. And I think it's probably the first Minister of Defense saying this. Think security from design. Wherever you are working in the space sector, you need to think about security from the very beginning of your program. And this is probably because people from the space sector are always thinking about safety and a lot of hazards and risk management. But this is also a new aspect of security that should be also taken into account. Build resilience. We need to build resilience. The economy should be resilient to space events that might have big consequences. Military should be resilient to space effects, meaning we should train without GPS, we should train without satellite communication, we should train without satellite images for intelligence. We need to increase awareness in intelligence. So like what said, more space situation awareness. This is a very capability gap that has been recognized for all nations. We need to invest more in space situation awareness and space object tracking. And also intelligence, with 2 L, sorry, for knowing what this object, okay, is it an active or a satellite or a debris, but what does it do? Which payload is on board? Who launched it? For what purpose? Was it declared or not? That's a bit more than space situation awareness. And of course, our small Belgium, we need to do this in a cooperation environment and in order to also enhance, for example, soft law initiative in a cooperation environment. So cooperation, and more cooperation, this is a Belgian motto. As a conclusion, join us. You can do a lot of jobs in the military. I cannot guarantee you that you will work in the space sector if you join us, of course. But specifically for next year, we are probably recruiting a space weather specialist and some imagery analysts, that's for sure, at least 2 posts, probably 3 for imagery analysts that we are lacking a lot. But beside of that, there are also the reservist status when some specialty can be recruited for part-time expertise within the military. So that might be also an interesting status for some of you. Do you have specific questions?
Thank you. It's a very interesting presentation, and the thought that war will extend in space is a terrifying one, but one that cannot be ignored, of course. I suggest that we will take one question now for time's sake, and then if time left at the end of all presentations, you're still free to ask specific questions to our presenters. I have seen a very interesting question in the Q&A, and that is, what is the impact of new technologies such as artificial intelligence on the
it is a very big impact. So typically, imagery analysts in the past, they were just like drawer and vectoring stuff on satellite picture to make maps of it, which is not the case anymore. Artificial intelligence has really changed the work of imagery intelligence analysts. And they are now validating a lot of proposition of pattern recognition, detection change that are implemented for them and that are really transforming their job. They have to deal with much more data from higher spatial resolution, higher temporal resolution, higher radiometric resolution, higher spectral resolution. So they are receiving terabytes of data that they have to deal with. So that's the challenge. And of course, artificial intelligence is the biggest key to their problem.
Thank you for your answer. So we will have time later today for more questions, but I would like to continue to our next speaker, Mr. Nicolas Vandroogenbroek. He's an engineer with almost 25 years experience within the IBPT, and the IBPT is the regulatory body responsible for regulating the electronic communications market, the postal market, and the electromagnetic spectrum of radio frequencies. He is currently responsible for the spectrum strategy and the authorizations of public mobile operators. He has been deputy head of the Belgian delegation at the World Radio Communications Conferences since 1997. His presentation will tell us more about the new radio frequencies management for short duration missions. Mr. Vandroogenbroek, the floor is yours.
Thank you, Sarah. Good afternoon, everybody. I will try to share my screen. Okay, it seems it works. So the structure of my presentation is the following. I will give a few words about BIPT, then what is frequency coordination, the ITU, what do we mean by short duration missions, and finally the results of the last World Radio Conference. BIPT is the national regulatory authority responsible for the electronic communication market, the postal market, and the spectrum of radio frequencies. What is frequency coordination? The main goal of frequency coordination is the interference-free operation. So I give you different examples of application using radio, which are very different on the coordination point. So the first one is the Wi-Fi. Everybody has a Wi-Fi repeater at home now. So the distance of coordination for Wi-Fi. So by distance of coordination, we mean distance reference to the user. It's 200 meters. So for Wi-Fi, there is no coordination procedures. And of course, there is no international coordination required. The second example is 4G base stations. For a 4G base stations, the distance of coordination is up to 20 kilometers. So it means that if you put 4G base stations at your border, you can interfere up to 20 kilometers in the neighboring country. So for a country like Belgium, it means that you have to coordinate your 4G networks with at least 4 countries. So for the international coordination, you organize a meeting with 4 other people. You are 5 in the room, and you can solve all the issue of 4G coordination. So for terrestrial television transmitter is the same, except that the distance of coordination is a little bit higher. The fourth example is a non-geostationary satellite. So the satellite is in orbit around the world. So it means that you have to coordinate with all the world, all the countries in the world. So it's not possible to put everybody in a room. It's not easy. So you need an international body for satellite coordination. So this international body is the ITU. ITU means International Telecommunication Union. So the ITU is a United Nations agency for ICTs. There are currently 193 member states. Belgium is one of those member states. The role of the ITU, there are 3 parts in ITU. The first part is the Radio 1. So it's responsible for allocation of global radio spectrum and satellite orbits. So it's a little bit larger than only the coordination of satellite. The second part is for the development of technical standards, and the last part is for the improvement of access to ICTs to developing countries. So one of the main documents of the ITU radio part is the ITU radio regulations, RR. The radio regulation is an intergovernmental treaty, so governing the use of spectrum and orbit resources. It defines the rights and obligations of member states in respect of the use of spectrum and orbit resources. And this radio regulation is updated every 4 years by a World Radio Communication Conference, WRC. Last conference was last year in November, and the next one should be in 2023. Except if there is some change due to COVID. So the coordination procedures at ITU, there is two main approach in the radio regulation. The first one is let's call it the light one. It's for satellite networks not subject to the full coordination procedure, and the second one is the full one. It's of course for satellite networks subject to the full coordination procedure. So if we start with the full coordination procedure, it starts with a coordination. So let's take the example of a Belgian company that want to launch satellite networks. They have to send the detailed description of the satellite network to BIPT. Then BIPT will send this description to the ITU, and ITU will publish this detailed description in a weekly circular, and this circular is available to all the members of the ITUs. So for the full coordination, there is an examination made by the ITU. So it means that the ITU check different provisions of the radio regulation are respected. The second step, and the most important is the negotiation. So let's take an example. If in Vietnam they can send a message to BIPT, to Belgium, and say, okay, there is a risk of interference from their own satellite networks in Vietnam. So you can receive comments from 10, 20, 30 countries, and you have the obligation to negotiate with all those countries and to find a solution. And so it could take months, even years sometimes. So at the end of the process, when you reach to an agreement with all the involved countries, there is a notification to the ITU. So you send the final technical characteristics to the ITU, and it's recorded in a database called Master Register. And then you can put into operation your satellite network. The second approach, which is the light one, it's just called the advanced publication information. So instead of sending a detailed description, you send only a general description of the satellite network. There is no examination by the ITU, and there are no obligatory negotiation. Of course, you can take into account the comments of the other countries, but there is no mandatory negotiations. And the end of the process is the same, so it's recorded in the master register, and you can bring into use your satellite network. So it's much less longer. Short duration missions, I will put directly in. So by short duration, it means that the lifetime of the satellite is short, typically less than 3 years. Short duration missions are typically composed of small non-geostationary satellites. So a small satellite is often called a CubeSat. So it's a small satellite compared to the normal satellites. It means that it's much less expensive to be built. It's built, it takes much less time to be built, and you can launch it into orbit much easier than a normal satellite. There are a lot of variety of applications with the satellites, but there is a common need of frequencies for telemetry, tracking, and command. But before the conference of last year, those satellites were subject to the full coordination procedures. So it means that sometimes the coordination process took more time than the lifetime of the satellite. And of course, it could have a cost. And there are also a lot of human resource costs, because if you have to negotiate with 10 or 20 countries, it takes time and it takes human resources. So there was a need to make new regulatory procedures that take into account the short development cycle, short lifetimes of short duration missions. That's what happened last year during the WRC 19. So the conference identified 2 bands for the short duration missions, one for the uplink, one for the downlink. And for those 2 bands, there is a new simplified regulatory regime for non-GSO satellite with short duration missions. So it means that there is no need to full coordination procedures, but only the light one. So it will take much less time. But the conference also decided that there will be no change for other bands than those 2 bands. So if you want to launch a CubeSat and use frequencies, you have 2 possibilities. The first one, you use the 2 bands identified by the last WRC. So it means that the coordination process will be much shorter, but the drawback is that the risk of interference is higher, of course. And the second one is to use other frequencies, and you have the full coordination process, but the risk of interference is, in this case, very low. So there was 2 criteria decided by the last conference to be considered as a short duration mission. So the maximum period of validity of the assignment, so it means the lifetime of the satellites, has to be lower than 3 years. And the number of satellites of the constellation shall not exceed 10. And I think it's the end of my presentation. Thank you.
Thank you, Mr. Vandroogenbroek. Also thanking you for sticking through the time. I was wondering, are there any questions from the audience here or from the people that are watching us? I see one question. So we have a question from Benjamin Lenormand. What is the benefits of the short duration mission process over the non-coordination process? So what is the benefits of the short duration mission process over the non-coordination process?
So the benefit, if you use this process, because you are not obliged, of course, to use this process, is the duration of the coordination. It's much lower, of course. So it takes less time and less resources. And of course, the drawback is that the risk of interference is much higher.
Okay, thank you. If there are more questions, then we will take them after the last presentation. And I would like to introduce the last speaker of today, Mr. Andrew Williams. Dr. Andrew Williams is an external relations officer at the European Southern Observatory, and that is an intergovernmental organization of 16 member states that constructs and operates world-leading astronomical facilities and fosters international cooperation. Andrew supports strategic relationships with current and future member states, with the EU and international organizations such as the UN. Prior to ESO, he worked as senior policy advisor for NATO and as a physicist for the UK government. And he also holds a degree in physics and public policy. The title of his presentation is Overcrowding the Orbit, Which Impact for Astronomical Observation. And Mr. Williams, Dr. Williams, the floor is yours.
Okay, thank you very much. Can you see my slides okay? Can you hear me?
Yes, we can see them.
Okay, perfect. So it's a great pleasure to be able to talk to you this evening. So it's a really exciting and interesting time to be in the space sector, as we've heard from the other presenters. You know, it's a growing sector in many countries. There's many fantastic and interesting jobs coming up. It provides essential capabilities for understanding climate change, enabling global internet, and really exciting exploration programs going on in NASA and ESA and in other countries. But with any growing sector, there comes challenges in terms of how this growth impacts in negative ways on the environment, as we've heard, or on other sectors that use space. And as young professionals in the sector and students, these are the issues that you will face, and you can play a role in addressing these challenges. And one of these challenges is that the space sector, well, mainly the development of satellite mega constellations, will have an impact on astronomy. So today I'll cover what this impact is, what we're doing about it, and what can be done in the future. And this is an area where there are obviously technical solutions that can be employed, but I think the core of the problem lies in the policy and legal thinking and forging new international agreements. And in a way, this challenge is a symptom of the policy issues that Ward Munters, for example, mentioned in his presentation. So before I start from where I'm coming from, so I'm working for ESO, which, as Sarah said, is an intergovernmental organization for ground-based astronomy, which means that it's founded on a treaty ratified by national governments. We have 16 member states, and actually Belgium was one of the founding members in 1962. And you're probably aware of other treaty organizations such as CERN, and of course the European Space Agency. And the good thing about this legal form is that it allows stability and structure, long-term planning, because states have to commit at a high level. It's really allowed Europe to become a leader in certain fields and achieve things that no one European country could really achieve alone. And one of these projects is the forthcoming Extremely Large Telescope, or the ELT. And as this is a Belgium conference, I thought you might want to see a familiar landmark. So it really is extremely large. It's going to be the world's largest optical telescope. It's going to have a 39-meter main mirror and will allow many amazing science discoveries. So the construction has started now, and there are some interesting jobs coming up. So keep an eye out on the ESA webpage. And actually on that matter, just wanted to mention that there's a careers fair taking place tomorrow, starting at 12. So you can sign up to this website and talk to some of the recruiters from CERN, ESA, and also ESO. But back to the main topic. So the astronomy community obviously knew about satellites. Occasionally they would appear in an image. They were aware of the radio interference problem. And of course we use satellites, for example, the Hubble Space Telescope. But no one really anticipated this optical issue. And we were really taken by surprise when SpaceX launched their first set of Starlinks. And you saw the result, which is this video that should be playing at the bottom here. And after the SpaceX launch, there was a huge public and media interest, and actually SpaceX started to get in contact with the astronomy community. So this is why astronomers are concerned. There's kind of famous image now that's been in all the media. And, just to say that astronomers have to schedule their telescope time a long time in advance. Quite often they're competing for it. So when they lose an image, it's actually quite disruptive. So this first image here, this is from a 4-meter Victor Blanco telescope, which is a US observatory in Chile. And you see a 300-second exposure. This is quite a wide field telescope, 2.2 degree field. So just for reference, the full moon on the sky is about half a degree. And it's these wide field telescopes that are expecting the most impact because they see a large area of the sky, and there's just more probability that a satellite will pass through. So the facility that will be most is what's called the Vera Rubin Observatory, which is another US-led project in Chile. It's coming online in 2021. And this one has a 8-meter mirror, so it's very big, and a 3.5 degree field of view. So remember that the full moon in the sky is half a degree. So this is looking at a wide section of the sky. And this is huge importance for astronomy. It's going to take a picture of the entire night sky every 3 nights. It's going to catalog billions and billions of solar system objects. And it has a very important project for the discovery and monitoring of near Earth objects and getting early warning on those that might actually threaten the Earth. It's also going to provide a source for other observatories around the world. And we can see some on this slide. So the one at the bottom here is the ESO's Very Large Telescope in Chile. And then on on the right-hand side here, we have radio observatories. So from at the top, we have ALMA, at the bottom, the forthcoming square kilometre array. And these ones suffer a different problem, which is radio interference. And the era of satellite mega constellations is bringing this challenge to a whole new level. So in the past, if you wanted to build a radio observatory, you could find a remote area, as you can see on the picture on the bottom here. And you can pretty much rely on making local agreements. You know, as we saw, you can coordinate up to 20 kilometers for the cell phone signals. And you can rely on being able to see in the radio astronomy bands that are protected by the ITU, but also you can go outside because there's just nothing else around there. Now we're talking about the whole world being covered in tens of thousands of satellites, all transmitting in, you know, the legally allowed radio spectrum. Of course, it's going to be a problem for radio astronomy. So why should we care about this impact? Well, I think one of the great values of astronomy is that it offers the possibility to ask and maybe answer about fundamental questions like, is there life on other planets? So this top headline, you know, comes from the discovery that was made on Venus a couple of weeks ago, the discovery of a chemical in the atmosphere that doesn't have any other plausible explanation for its existence other than that there's life. Well, I mean, with our current knowledge. And, you know, this is a really kind of fundamental question for humanity, I think, to know if we're alone in the universe. And, you know, on the right-hand side here, you know, this famous image of the black hole, you know, this is an iconic finding that will appear in textbooks for years to come. It's been hugely important in our fundamental understanding about gravity. So how can we place value on this knowledge? And then below, as I mentioned earlier, astronomers provide the world an essential service to monitor the skies for potentially threatening asteroids. So the wide field survey telescopes that do this will be impacted in their abilities by satellite constellations. And in fact, the first detected interstellar asteroid on the bottom right here was found with one of these wide field survey telescopes. So constellations. Here's a definition, a number of similar satellites of similar type and function designed to be in similar complementary orbits for a shared purpose and under shared control. And I'm sure you're all familiar with that they will perform some important and possibly revolutionary functions in terms of stimulating new areas of the economy. So GPS, telephones, Earth observation. I learned some new things about how Earth observation is actually used by lawyers. I think that was really interesting earlier. And of course, the way that SpaceX and Amazon and OneWeb are going is the global satellite internet. So an important factor in this technology is the signal latency, which is the time that it takes signals to move from the ground to space and then back down to the ground again. And previous systems, which are much further away, it takes a long time, so you get this annoying delay. And what SpaceX are doing, for example, with Starlink, is they're going much lower into low Earth orbit, you know, 300 to 600 kilometers. And this makes certain design characteristics about the system that leads to certain choices that have a huge impact on astronomy. So one feature is the characteristic of the antenna beam. So you can see this picture here. The red circle is a Starlink beam footprint. The blue circle is a OneWeb beam footprint, and I think the green one is Telsat. So the Starlinks, they have many satellites, but they're going to be low, so they can have this smaller beam footprint. Whereas the original OneWeb plan was to have fewer satellites, but they're much higher, but that means that they have to have a very wide beam footprint. And of course, you can see, you know, this is a huge area of the eastern seaboard of the United States that it covers, and you can see the difficulty that it poses for radio observatories. And then from the optical side, the lower they are, the brighter they are in the sky, whereas the higher they are less bright, but then they stay in the field of view for longer. So this is an issue. And of course, it's not just astronomy, and we've already heard about this, but it's a problem of space debris. And of course, this is, there's a policy gap in this area that really needs to be filled. Okay, so what have we done in astronomy? Well, we have done some nice simulations, and this is the result in more or less one slide. So here you see a kind of mapping of all the planned current and future satellite constellations about which we know. So the vertical axis is the number of satellites that are illuminated above 20 degrees of the horizon, and this is because most astronomy observations are performed above 20 degrees. Now, I'm not going to mention too much about what's happening below 20 degrees, and it's actually the problem is kind of worse. So if you're in a dark sky area, you will see many satellites on the horizon, and of course that's another problem in itself. So then on the horizontal axis, we see the satellites below the sun, the degrees of the sun below the horizon. So on the left-hand side, this is sunset, and then on the right-hand side, you're getting more into the night. So if we look at this red line here, this is the full Starlink constellation. And this shows us that at astronomical twilight, which is this white band here, when most astronomy observations start, there'll be about 100 satellites visible at any one time above 20 degrees. If we look at the blue line here, this is the full OneWeb constellation, and you can see that the problem is much worse. So at the start of astronomical twilight, there's going to be over 1,000 satellites illuminated by the sun at any one time, and of course this is a problem, and it's going to cause real headaches for the wide field facilities. So what are we doing about it? Well, we've done the studies, we've done simulations, and even some observations of the satellites using telescopes, and we have a kind of basic understanding of what the immediate observatory and industry mitigations could be. So these range from changing our practice a little, so changing the way we schedule observations, doing post-image analysis where possible. And some of this actually requires data from industry, so we need to have a much higher precision information about where the satellites are in advance. And you can imagine this becomes difficult of commercial reasons, but you can also see the linkage to solving the space traffic management problem with this issue. The industry can take two very important steps. They can make their satellites as dark as possible and keep them as low as possible, because higher satellites stay for longer in view overhead, and they're kind of more in focus to the telescopes. So,
Dr. Williams, sorry to interrupt you. We have reached 15 minutes, so if you can round up your presentation, please. Yeah. Thank you.
So no combination of impacts will actually solve this other than not launching them. But of course, that's not a problem. So we've done some collaboration with industry. So this is SpaceX. They've made 3 specific steps to solve this problem, and this is progress. But this gets this fundamental kind of policy question. These things are going to be viewed by everyone on the entire planet, and who has the right to decide this? Who has the right to the night sky? And of course, this is what I'm talking about here. This beautiful scene. So, to conclude, there is work to be done. I think now is the right time to really kind of shake up the regulatory landscape in this sector, and we need to continue the work with industry. So anyone who's going into the space sector in the audience now, you can consider yourself aware of this problem. And I think the last most important point is that we're really saying that the international governance and kind of legal framework has really been stretched to the limits in terms of its ability to deal with these conflicts of interests. So we need new legal and policy thinking on this subject. So over to you.
Thank you so much, Dr. Williams. We noticed that you're already in outer space, so we hope to follow soon. Thank you to the speakers of today and for their insights. Personally, I learned that we definitely should start governing space traffic management by keeping in mind that Star Wars might become real. So we better join the army now if we want to be a first space soldier in Belgium. We also learned again about the importance of frequencies and the big books of the radio regulations. And definitely there's much more work for future space professionals by keeping an eye on asteroids as well. I promised we would take some time now to have more questions. Maybe first a question for Dr. Williams. Is there anyone in the audience who would like to ask a question to Dr. Williams? I'm checking our Q&A now. I have a question. Can we use the satellite imagery from higher orbits for astronomical purposes?
So satellite imagery from higher orbits, if the question is referring to kind of Earth observation, I'm not sure there's so many uses for astronomy. If you're talking about putting a space telescope in higher orbits, kind of above the satellite constellations, then yes, absolutely. But the problem with this is that launching a space telescope is very expensive. The thing that drives performance in astronomy is the size of the mirror. So you want as big as mirror as possible. So, you know, if we can find a way to launch a 40-meter mirror into space, then this is fantastic. And, you know, we've seen the delays with the James Webb Space Telescope, and kind of in parts, this is due to the massive technical problems involved in trying to put a big mirror in space because of the cost of launch and the kind of challenges of doing that. So right now, the way forward for astronomy is we need a combination of ground-based and space-based facilities, because the ground-based, you can rapidly change the instrumentation, whereas the space-based, you get kind of really high performance and you're above the atmosphere and the satellite mega constellations.
Thank you for your answer. Are there any other questions from the public for one of our 4 speakers? Or maybe someone in the chat box or the Q&A, if there's some more questions. Otherwise, we will pick some from the questions that were already asked but not answered yet. I have a question. For those short missions, is there any specific rule for end of use? Otherwise, future mission might have problems in using those frequencies. I think this is a question for Mr. Vandroogenbroek. I maybe will repeat it. So for short missions, is there any specific rule for end of use? Otherwise, future missions might have problems in using those frequencies.
Yes, the rule is quite simple. So there is the 3 years limit. So after 3 years, your record in the master register of the ITU is not valid anymore. So it means that you have to switch off the transmitter of your satellite.
Thank you for your answer. Maybe any other questions? Otherwise, I can pick again one from the questions that are asked. This will be a question for Mr. Munters. A couple of days ago, ISS moved its trajectory to avoid space debris. Has been any political or legal implications in this regard? You need to unmute yourself, Mr. Munters. Yes.
Right. I noticed just in time. I've been extraordinarily busy the last couple of days, so unfortunately I cannot share on the specific incident. But yeah, one thing that's not often talked about, we always talk very abstractly about, oh, this space object or this satellite might collide with this satellite. But at the same time, you have a lot of these ideas, ideologies that want to populate orbits, that want space travel to become commonplace. Well, if there's a lot of debris, there's a lot of risk of it hitting inhabited space satellites or space stations as well. How are you going to manage this? If there's particular orbits that are heavily populated with human presence, astronauts, cosmonauts, taikonauts, what have you, space travelers, space tourists, do we need to actually manage these orbits in a different manner to make sure that, for instance, there are no other objects that might collide? How do we manage all of this? These are all questions that lie at the basis of space traffic management. And then really quickly, the issue of radio frequency interference is extremely interesting because what we're dealing with is basically the following. We've had an international system to manage electromagnetic spectrum from the very beginning. The ITU was very quick on the ball a year after Sputnik was launched, and they noticed a little bleep causing interference on radio frequencies. What space traffic management tries to do conceptually is also avoid interference, but not between states in the electromagnetic field, but interference between material objects in a gravitational field. The whole structure of modern radio law exists more or less to deal with the specific issue of radio frequency interference. So if you want to get an idea of the magnitude confronting us regarding the construction of a space traffic management regime, you can basically infer from radio frequency interference the fact that the whole structure of space law, orbital space law as I like to call it, will probably be based on trying to avoid collisions kinetic interference. So I'll leave you with that little conceptual note.
Thank you so much. I have a follow-up question for Mr. Vandroogenbroek. Is there any way to control if the frequency has been switched off?
Yes, you can just measure if you still receive something from the satellite, yes. And if it's not the case, of course, there is an international treaty. If one part doesn't respect the treaty, okay, you can declare the war, but I don't think it's the right way to proceed.
Thank you. Any more questions from the audience? I'm just checking here live. Yes, Arthur, please. We will need a microphone for you. One moment, please.
My question was actually a question on the success of this new regime, because I also actually researched the topic of last year of the new, system for short mission disposals, and I was thinking, okay, great, we have a lot of progress, but as you just mentioned, it's just for 2 bands. What can you tell from the Belgian perspective on the success of the use of these bands? Are they being used more often, or do we just realize that actually this new resolution is not that, resolving?
Okay, it's really new. So in Belgium, maybe last 5 years, we have 4 or 5 satellite networks. So we have just only one since the entry into force of the new rules. But this one doesn't use the frequencies identified by the WRC. So we have not yet any feedback with those frequencies. But I think it's a good solution for if you have a satellite and you don't have a lot of resources. Yes.
Thank you for your answer and for your question. I'm still checking if we have more questions. I have a question. If you ask a question, maybe you can also mention in the chat box who you want to ask the question to. So I will now try to appoint a speaker. If a satellite has an impact by a piece of space debris, do we know who the owner of the debris is? And if we know, does the owner has to pay for the damage? I think, Bart Munters, this is again a question for you, or maybe Dr. Williams is willing to help answering. I leave it up to you.
If Dr. Williams wants to take the floor, that's okay by me. Otherwise, I'm more than willing to answer. Okay, well, if a piece of space debris hits a satellite, well, of course, one of the big problems with the liability convention, the 1972 liability convention, is that, yeah, first of all, you need to know whose piece of space debris is it. There are certain physical models. Maybe if you've cataloged it with a radar, tracked it since its inception, you might know whose piece it is. But a lot of times you won't be able to identify where the debris comes from. Now, from an accountability perspective, of course, if you don't know who damaged your satellite, you won't be able to go ask them to pay for damages. Further, I think there's not been a single international case based on the liability convention, with perhaps a slight exception for the invocation of of absolute liability for Earth-based damages when Cosmos 954 came down over Canada and basically sprayed nuclear material over Canadian territory, unpopulated, luckily. But the whole question of liability, in my opinion, is basically a moot point. The whole issue in orbital space is preventing collisions. And now, while I can appreciate the fact that, for instance, industry or commercial interests might want to have a stick behind the door, so to speak, to be able to claim damages once their fancy satellite gets hit, we're moving towards an environment where satellites are becoming disposable, mass-produced commodities. Look at Starlink, look at SpaceX. So liability is actually looking at it the wrong way. And I think we should really try and expunge this idea from our minds altogether. Namely, what it does is force you to think about the problem retrospectively. Namely, a collision happened, who was responsible, and who are we going to make pay for it? That's the completely wrong approach to the problem, in my opinion. Namely, you need to look preventively. Once the collision has happened, for all intents and purposes, when it comes to sustainability, safety, and security, it's already too late. So liability, in my opinion, has little or no value in orbital space at this moment in time, at least for fault-based, space-based damage.
Thank you, Mr. Munters. I have a question for Mr. Nicolas Gérôme. How will the EU respond if there is a collision between an ESA satellite with an American, Russian, or Chinese satellite?
Well, if the case is about two active satellites, it would be very, very problematic, obviously. If it's one active and one debris or inactive satellites, that's a case that already happened, like the Iridium and the Cosmos satellite. The fact is that it's an unlikely scenario, except if it's two small satellites. That would be with a lower maneuver possibility that could happen. And of course, like Ward said, there is the question of liability and so on. And I guess space law will benefit a lot of that incident, because it would be a very nice event to evolve space law, probably, because that would be a premiere. But I think the most likely scenario would not be like that. If it's an aggressive act, it would be probably a small commercial satellite, NanoCubeSat or CubeSat, that would have malfunctioning, these problems, and that might be hacked, for example, towards another one. And then forensics is very complicated, of course, if a collision occurs, and proving that what happened, from who it was done, and so on, would be completely impossible. Mm. So, and that's the problem, that it's a big an allusion and a similarity with the cyber world, when you can attack someone and the attribution is very complicated. In space, it would be the same. And the fact that an attack or an aggression or an hostile act is complicated to attribute to someone, because you need to have historic of that specific object, where it was launched, for what purpose was it, registers, and so on. It means that it's complicated to attribute the act of aggression or the jamming or whatever. So it means that the threshold to decide to use it is lower than for an act of aggression on Earth, when you know who has bombarded you, but you don't know who has hacked your satellite. So it means that it's more likely to happen.
Mm. Yeah.
Sorry to give all the bad news here today.
Thank you for your answer. I see that our time is coming to an end. I'm checking with the organizers. Maybe one last question? Do we have time for one last question? Yeah, okay. We will take one last question. I see a question. Who will be taking the lead in space management? I think, Mr. Munters, that is maybe a question for you again.
Well, space traffic management is a popular subject. We'll take the lead. Well, just look at the most technologically advanced actors. You've seen this happen historically in all sectors. Who were the powerful colonial imperial interests in the 16th, 17th century? The nations with the strongest naval technology. They were the ones that went on to conquer the world. Who is the one with the strongest technology now? Without a single shred of a doubt, the United States of America. They have the best radar technology, the best imaging.
I'm afraid that the connection is going a bit
the
bad.
best operation in the last couple of years.
Now it's restored again, so please continue.
Okay. Well, without any doubt, the United States of America is the most powerful actor. Now, what their position will be, we've heard rumors. There was a lot of rumoring. Perhaps they're still going forward with it. Was to commercialize their space data segment, take it from under the military and put it under Department of Commerce. That might happen. But the question, again, let me end on a critical note and perhaps a bit pessimistically, but ask yourselves this. If you are somebody, an actor, in possession of the only technology or the best technology that allows you to image the space environment or to stay active in the space environment, do you actually...
The connection was going bad again.
Okay, sorry.
I'm sorry to interrupt you. I think we can maybe better continue with a last question. Thank you, Mr. Munters. Sorry to interrupt you. We have a last question for Dr. Williams. What are some examples of interdisciplinary jobs in STM other than law-focused jobs?
Yeah, I think this is a really good question, and I think it also applies. You know, we usually think of jobs in space from a kind of technical perspective, in engineering, and there are things you can do that are very interdisciplinary. So actually, my own profession, which is, I guess you could call it government relations. So this is all about finding funding, managing issues with stakeholders, being a conduit into the organization from outside, solving problems and kind of high-level advocacy. And what this really requires is a broad knowledge of technical aspects, but also policy and legal issues. And then another important job for the space sector right now is communications. So, every company, every organization has a communications function, and they need people who are good communicators, but also technically knowledgeable. And then I'd say a third category could be kind of general policy jobs. I'm not so sure that these really exist in industry, but certainly all the government organizations, European Space Agency, they have people who are hired to kind of conduct research effectively on policy issues that affect the organization and kind of look out into the future and make sure that the organization is prepared for that. And again, this is something that, if you're a lawyer, then that's fantastic. But also if you have a technical background. So I started as a physicist, and I sort of gradually worked my way into kind of international relations. And I think having this technical background has been really helpful in my career.
Yes, I can imagine. I only had the possibility to have some physics courses, but if you have a technical background and combine it with a legal or policy background, I think then you're off to get a job in space. Thank you so much for your answer. I would like to thank again the speakers of today for their time. Also thank the participants here in the Egmont Palace and also participants watching at home. I don't know if there is any final words of the organizers that needs to be said. Then I will now give the floor to Ms. Amelie Revers.
Thank you. So Sarah, we would like to thank you as well as a chair of this topic, and as well Dominique Tillmans for all this organization.
Yes, and don't forget that Switcher Space continues in the next few days. So this is the end of topic 1. We have 7 more topics, with tomorrow topic 2 on life science and microgravity. So how does the human body adapt or not to space travels? And we have again prestigious speakers such as Jérémy Rabineau, Kevin Taburi, Vladimir Pletzer, Bjorn Bazelet, Baptiste Leroy, and Karine Van Donning. So please stay tuned for tomorrow, the next topic of Switch to Space. That's it. Thank you for being here. Have a nice evening.